For the today lecture, we are going to discuss the different states of matter. And the second major objective of today lecture is how can you differentiate between the different states of the matter, and actually what are the physical properties which we have already discussed in the previous lecture. So what are the physical properties based on which you can differentiate between the different states of matter? So this is our today objective, and we will cover all these areas. And later on, we will do some very simple exercise so you will easily understand what would be the different states of matter and how they are converted from one state to another state. And this is also one of the main and the major objective of today class. So again, we are going to discuss these states of matter, and then we will discuss the different properties on which you can differentiate the solids, liquid, and the gases. That means the states of matter. And later on, with the third objective, we will discuss how one state is converted into another state, and what are the specific or the proper terminology to be used for this conversion of the state. And this is called the transformation of the matter. Remember, with the definition of the chemistry, we actually define it is the composition and the properties of the matter and the transformation of the matter. So here we have discussed already two things, the properties and the little bit about the composition, and we will move to the composition later on because we have a specific topic on this. And today we are going to discuss the third property or the third form of the chemistry which is going to define, that is called the transformation of the matter. So this is the transformation of the matter, that how one matter is converted into the other one. And we will study very simply, and there will be no any too much burden on you to remember or memorize the thing. So just look at what I'm going to explain over here. So first of all, so here actually four states of matter are given. One is the solid, other one is the liquid, third one is the gas, and fourth one we discuss under the heading of the plasmas. So these states of matter, one important point over here is how one state of matter is converted to another state of matter just by adding the energy. So if you provide the energy to the solid, and then the solids will melt and convert it into the liquid. And further, if you provide the energy to the liquids, they are going to evaporate and convert it into the gases. And still, if you further provide the energy to the gases, they are going to be ionized and they are formed the plasma. And this we are going to discuss in today's lecture. And these are the actually the three forms of the water. It is the ice. When you give the heat to the ice, it is converted into the liquid. And when you further provide the heat, the liquid is evaporated and converted into the steam. That is one form of the matter, and it is called the gas. So basically, with your course content, these three states of matter we are going to discuss basically, and this we study in the higher classes. So solid, liquid, and the gases. So this is up to your course content. Again, now look at what is the proper differentiation between these different states of the matter. Again, solid, these are the liquid, gas, and the plasma. So one important thing is, as displayed over here, these are the properties. It is let's suppose it is the lead is in the solid form, or it is a wood, it is the liquid, or this is like a cloud in the gaseous form, and then this is the ionized when there is the sparking in the presence of the ionized. And you, this phenomena you also see in your daily life during the rainy season as well. So look at, actually this is the chemistry. And we are going to define why or how solid is different from liquid. And these are the molecules. Let's suppose if this is a lead, this is the each atom of the lead, or the iron, or the any of the other element. Let's suppose it is the carbon. If you are sitting on a wood chair, so it may be a carbon. If you are sitting on the iron chair, and it may be the atom of the iron. So they are closely packed to each other, and you can see if they are closely packed, they mean the attraction of one molecule or one atom with the other atom is strong. That's why they are forming the solid molecule. And now if you provide the heat over here, then what is happening? These atoms or the molecules are uh, actually departing away from each other. Now the distance between the atoms is more as compared to the distance or the attraction between these two atoms. So that means the forces between these two atoms or the molecules are weaker. That's why this is in the form of the liquid. And if you provide further heat to the liquid, look at this position. So these two atoms or the molecules, now they are further away from each other. That means now the forces between these two molecules, and I am talking about the forces of attraction, how one molecule or the atom is going to attract with the other molecules, and this become again weaker as compared to the liquid, and the liquid is weaker as compared to the solid. So this is very clearly displayed over here. And that means now if you provide the heat to liquid, it will be converted into gases, and the actual reason is over here is the molecules are away from each other. That's why the attraction between the molecules or the atom is very weak. That's why they are in the gaseous form. And now, and again, this is just additionally I am going to consider this form, but it is not in your content. So if you further provide the heat to the molecule, so now remember each molecule or the atom is having a nucleus, and there are some electrons in the extranuclear part over here. So what is happening if you provide the heat? These electrons are removed from the outer shells. So these molecules or the atoms become ionized. That means electron is having a minus charge. If one electron is removed, and that means this is the let's suppose it is the electron removing from the atom. So there is a deficiency of the one electron over here. That means this will become the positive charge, and the electron is removed. So simply if you provide the further heat to the gaseous molecules, they become ionized, and this form of the state is called the plasma. So this is the basic reason behind the transformation of the matter. That means the forces of attraction between the molecules or the atoms become weaker when they are transformed from solid to liquid, liquid to gas, and gas to the plasma. So again, now look at the further. Now, as I have said before, there are some of the physical properties you can differentiate based on the physical properties. Uh, that means how the solids are different from the liquid, and what is the appropriate term to be used when one form of the solid is converted into the liquid. And all these terms are very relevant to you because all these terms you are using in your daily life. So basic chemistry, this is chem 100, is basically is to equip you with the basic knowledge. That means you must remember the appropriate chemistry, and what is happening around you with the appropriate terms to be used to define the phenomena, what is happening when one form of this state is converted into the other form. So remember, I am going to discuss here only four properties. So this may be your assignment. So listen carefully, and if you find any difficulty, I am here to describe further. So here in this slide, I'm going to describe four properties, the physical properties of the in general the four properties on which you can differentiate the solid from the liquid or liquid from the gases. And second, the proper terms. These are the terms written over here. I'm going to explain over here, and these will be used to be used when one form of the matter is converted into the other one, maybe the solid into liquid or the liquid into the solid. So first start with the properties on which you can differentiate the solid from the liquid. So the first two are written in the first point. The number one is the solid must have a fixed shape and fixed volume. That means the volume that is not going to change for the case of the solids. Let's suppose if you have again, if you are sitting on a chair, it is in the solid, it must have a fixed shape. It will remain with the same if it is a chair, if it is a table, and if it is a laptop. All these are the solid. That means they must have a fixed shape over here. Sorry. And sorry. So fixed shape, that means they have a fixed shape, and the volume is, that means what is the capacity to hold the volume of that particular solid will remain the same. Let's suppose if it is a glass or the ball, what volume it is going to occupy, it will remain the same. Volume is not going to change whenever it is the one specific solid. Let's suppose if it is a glass or the beaker you have used in your labs, if it is a 100 ml beaker, so the beaker is, it is in a solid, the shape will remain the same, and you can differentiate each time it is the beaker, and the volume that is going to occupy this beaker, that means if it is 100 ml, and the volume will also be the same. That means the first point to differentiate between the solid among the other state is the solids are having a fixed shape and the fixed volume. Again, this is the second point, and this I have described in the previous slide. Again, intermolecular forces are very strong, and that's why these are the solids, as uh, we have discussed over here. The intermolecular forces, intermolecular mean the between the molecules. Inter mean between, molecules are the molecules. Intermolecular forces, the forces between the molecules. So this is the molecule, this is the molecule, and these are the forces between the molecules. These are the forces between these two molecules. So here intermolecular forces are very strong. So that's why they are in the solid state. The the fourth point is the motion of the molecule is very small, or you can say because the molecules are fixed, they can only vibrate. They cannot move from one away from the one molecules, or they because again, if they have a very strong intermolecular forces, let's look at this molecule. This molecule is have an attraction with this molecule, this and this. That means it is fixed within the molecules, and it must have a strong intermolecular forces between the other molecules. So this is not going to move out of here unless you provide the energy. So then it is converted into the liquid. But we are discussing over here, when it is a solid, then there is no movement of the molecules, or very small movement of the molecule. Vibrate mean they just only vibrate, like I am moving over here. They just vibrate. The molecules can vibrate, but they are not move away from other, like it is displayed over here. So very simply, you can based on the four properties, you can differentiate the solids from the other. It is having fixed shape, fixed volume, strong intermolecular forces, and the movement of the molecules is very small. So the second is the know, if you know or you have a knowledge about these four properties, now you can easily differentiate between the liquid and the gas. So because these are repeating over here, so what is happening over with the liquids, and the liquids is having the fixed volume but a shape that can be changed. And as here, the solid must also have a fixed volume. So one property is repeating over here. Solids also have a fixed volume and the liquid must also have a fixed volume. But what is the difference? It is a fixed shape, but the shape can be changed. And this is also a very common example in your daily life. Let's suppose if you put 100 ml water in uh, a glass, so that volume will actually make the same shape of the glass. That means the shape is going to change depending on what is your carrier in which you are going to put the water. So if the same volume you will put in a ball, then the shape of the actually that liquid would be the ball shape. So that means the shape can be changed, but the volume is not going to change. It will remain the 100 ml. If you are putting 100 ml in glass, 100 ml in ball, the volume is not going to change. That means the liquids are having fixed volume, but they have a change in shape. Again, look at the third property, intermolecular forces here are strong, but here the intermolecular forces are not strong as in case of the solid. You can say the intermolecular forces are weaker than the solids. It must be weaker from the solids as displayed over here, because here intermolecular forces are strong, but now the one molecule is away from the other. Now they are away because there are not too much strong intermolecular forces. That's why they are away from each other. So it means the liquid is having weaker intermolecular forces as compared to the solid. So this is the third properties of the liquid. The fourth one are, here we discuss a very small vibration because the molecules are packed together in the solids, but in the liquids the molecules are closely packed but do not have fixed position. The molecules slip and slide past one another, allowing the liquids to flow. And this is the common example. Let's say if you pour the water, so this is going to slide, and this you can say this is going to slip. And if you also pour, let's pour the liquid in the form of the honey, this is also going to be slide. One molecules of the one layer is going to slide from the other layer of the honey or the water. So that's why the movement of the molecules are the motion of the molecules are not fixed as in case of the solids. So they are freely moving in case of the liquid. So coming to the gases, again, look at actually the knowledge is what you are carrying the knowledge in the previous, and what actually additionally you are going to define the other states of the matter. So again, the first is it is the solid have fixed shape and volume, but here in case of the liquid are fixed volume but not shape. And in case of the gases, the two are variable, not fixed shape and not having a fixed volume. And this you can also define very simply, that if let's suppose if you have vehicles and it they may have a CNG cylinder inside, and one is the small cylinder, one is the large cylinder. And similarly, if you are using LPG at home, so maybe you have a very small cylinder fixed with the oven, and maybe you have a large cylinder. So actually, if you put the same 1 kilogram of LPG or the CNG in the different cylinders, so what would be the actually the shape? The first one is it will be the shape as the cylinder is having, because these are the molecules of the gases, they are spread all around the within the cylinder. So it will be having the shape of the carrier. If it is a cylinder, let's suppose it is, if it is 1 meter long, so whatever is the dimension, that would be the shape of the gas. And similarly, the volume is also not fixed. And as I have explained, if you take 1 kilogram of the CNG or the LPG in small cylinder or in a big cylinder, that is the volume of, what would be the volume of the cylinder, that would be the volume of the gas, because it, the molecules are away from each other, they are going to spread all over the cylinder, so it will be the volume of the gas. So that means the gases have no fixed shape and the no fixed volume, and this is the common practice you are observing in your daily life as well. And the second one is the sorry, this is, these are the two. The third one is the intermolecular forces, and say if they are the gases, and this is understood, the intermolecular forces are the weaker.
Sir,
Yes.
sir, can you explain how gases do not have a fixed volume?
Okay. Yes. Okay. So again, let me explain. The fixed volume mean, uh, again I have explained, because if you carrying a gas, if you go to the, let's suppose to fill your cylinder from any CNG shop, so if it is the uh, if you let's suppose ask the shopkeeper to fill your cylinder with 1 kilogram, and there are the two customers are going there, and one is having a big cylinder, and let's suppose the other one is having a small cylinder. So if the shopkeeper is going to fill the gas in both cylinder, so imagine what would be the volume of the gas in each of the cylinder. So that would be the same volume as the cylinder is having, because you cannot fix the gas. You cannot fix the gas. Just let's suppose this is, if it is a cylinder, if you put the gas over here, so it doesn't mean it will be, if it's a small quantity in case of the liquid. Let's suppose if you put the liquid, it may fill up to here. If it is let's suppose the 1 liter, and if you put more liquid, it will fill, let's suppose the half of this cylinder, it will be the 2 liter. That means here it must have a fixed volume. Whenever you put it, it is having the same volume, uh, what volume you are using to fill that particular cylinder. But in case of the gas, if you put 1 kilogram of the gas, it will spread all over the cylinder. It is not going to fix over here or to fix over here, because these are the molecules. And even you, if you spread the gas, sometimes there is a leakage in your home. So it is going to spread all over the atmosphere. That means they are not having the fixed volume, not having the fixed shape, so it will spread all over the cylinder. So if the cylinder is double, let's suppose if it is the double to this one, again if you put the 1 kilogram, the same amount of the gas over here, this is also going to spread all over the cylinder. That means in the first case the shape was like this, and this was the shape of the cylinder, and the other case it was larger or the bigger cylinder, then the shape was different, and that shape of the cylinder actually would be the shape of the gas molecules, because they are going to fill up in the whole cylinder, not to the specific part as in case of the liquid and the solids. So that's why they do not have any fixed shape and the volume. Is that clear, beta?
Yes, sir.
Okay. So next, the third one was the intermolecular forces, and here again, intermolecular forces are weaker as compared to here. So just you just remember this diagram. It will be easy for you to understand. And the fourth one, the molecules move freely without being held together. And this is the property of the gas here. Let's suppose if this molecule is moving freely because there is very weak intermolecular forces or no force of attraction between these molecules. That's why they are moving freely as compared to the liquid, and the liquids are more as compared to the solids. So these are the four properties based on which you have differentiated the solid from the liquid and the liquid from the gases, or any maybe you can differentiate from the solid from the gas. Now I'm going to use the proper terms, and these terms you are also using in your daily life. So the first is if the solid is converted into the liquid, and that term is called the melting. Like you say, it is a melting of ice. The ice is melted. So the term is the melting. So whenever the solid is converted into the liquid, this term is called the melting. So you must remember. And how it is converted into the liquid? By applying the energy. So if you add the energy, like it is indicated over here, we have explained in the first slide, and here even if you give the energy, they are converted from solid to liquid, liquid to gas. So if you provide the energy, solid is converted into liquid, and this term is called the melting. And opposite to this one is the freezing. Like if you put the liquid in the freezer, it will be converted into ice, and you can say this is called the freezing. So freezing is the term used to convert the liquid into the solids, or you can say when the solids are converted into liquid, that the point is called the, or the proper term to define this phenomena is called the freezing. And the freezing is happened with the release of the heat. So that means actually if the water is freezed and converted into the ice, that means you are removing the heat, and this is the actually the freezer is going to do with the liquids. That's why it is converted into the ice. So if the liquid are converted into gases, again this term is called the evaporation, and this is also very common terms you used. If let's suppose if you put the liquid in a ball under the sun, so after maybe the few, depending on the volume, maybe the few hours or 1 or 2 days, the whole will be evaporated. So you use, okay, everything, the water is evaporated, or that's why this term is used to define the conversion of liquid to the gases, and the term is called the evaporation. Again, this is happened after the absorption of the heat. When you provide the heat, this is converted into the gas. So this is opposite to the evaporation, and this term you also used. This is called the condensation. It is alternate to the rain. So let's suppose if there is the evaporation, when the water evaporate, it is going to the atmosphere, and again they are going to condense, and then the rain is going to start. That process is called the condensation. So condensation is the with the removal of the heat, and evaporation must be with the absorption of the heat, because if you want to convert the gas to the liquid, you must have to release the heat. That's why the condensation will start. So when the temperature goes down, no, that's why the rain is going to start, because this process is happening in the upper atmosphere. So again, two terms are left. There is the possibility when the solids are directly converted into the gases. This term is called the sublimation. So there are some molecules without passing to the liquid, they directly converted into the gases, and you will do some sort of the experiment in the lab. So you will better understand during the experiment. Here, just to remember, if the solid directly converted into the gases, this is called the sublimation, and opposite to the sublimation, it is called the deposition. So when gases are converted into the solids, This process is called the deposition. So this is all about our today lecture, and I have only 2 minutes. If any one of you didn't mark your attendance before, so first mark your attendance in the chat box with your name and the roll number. And remember, I first consider only those who have marked on time. So you must be regular. So you first understand the the objective of the course. So it will be helpful for you to understand the content of the course as well. So I am moving to the little bit the exercise. So with this exercise, these are the few points are given over here, and you may connect of one point to the other point, maybe this or this point to the this point, and define what is the this process is called either from this to this and this to this with labeling of these are the fundamental definitions over here with the states of the matter. And we have discussed melting, freezing, evaporation, condensation, sublimation, and the deposition. So again, we will move to the second slide. So this you can do in your notebooks. So just draw these line on your notebooks, and later on connect these line, and then explain very briefly what type of process is this to describe the transformation of the matter.